My dear students, now we are going to look at a octal to binary encoder. So we know what is encoder. So in the encoder, we have seen that there are 2 power n inputs and n outputs. So if you look at the encoder, there will be 2 power n inputs and n outputs. The n inputs, 2 power n inputs are like this. Of course, there will be n every input. Okay, there will be n outputs. Now we are looking for a special case that when n is equals to 3. When n is equals to 3, 2 power 3 is 8, and output, these are 8 input lines, of course, and n output lines, because n is equals to 3, 3 output lines. Since there are 8 inputs, I say octal input. Okay, and we are going to get the 3 output lines, which says which line is active. So which line is active? It is in the form of binary form. Output is in form of binary form. I can say binary output. So in simple words, what I can say is there are 8 inputs and there are 3 outputs, right? 8 inputs, 3 outputs. Of course, there is an enable input, which I am making it as 1. 8 line to 3 line encoder, which is known as octal to binary encoder. Okay. So now the inputs whatever we have, let's say data line D0, D1, D2, D3, D4, D5, D6, D7, output lines Y0, Y1, Y2, right? So when enable is 1, this works. This device is on. Encoder is on. When encoder is on, now let's look at input-output relations. What are the inputs I have and what are the outputs I have? So if I take the input-output relations, it is something like this. D0, D1, D2, D3, D4, D5, D6, D7. The output lines are Y0, Y1, Y2. So it is something like this. When D1 is G1, 0, 0, 0, 0, 0, 0, 0, output will be 0, 0, 0. So these are input lines and these are outputs. Input-output relations is known as truth table. Truth table of octal to binary encoder, right? So when the input is this is 0, this is 1, 0, 0, 0, 0, 0, 0, output will be 0, 0, 0, 0, 1. What I mean to say here is if y0 is LSB, it is better to write as y0, y1, y2. This is y0. Y0 is LSB, y2 is MSB. So we need to take care of that. Okay. So next is when this is 0, 0, when this is 1, 0, 0, 0. Which line is 1? D2 is 1. So your output will be G1, 0, 1, 0 means 2. Okay. Next is 0, 0, 0, 1, 0, 0, 0, 0. Then your output is 0, 1, 1, saying that the input line 3 is active. 0, 1, 1 is value 3. It says line 3 is active. Input line 3 is active. 0, 0, 0, 0, 1, 0, 0. Then I am going to get 1, 0, 0 because D4 is active. So output is 4. Similarly, 0, 0, 0, 0, 0, 1, 0, 0. Then it will be 1, 0, 1. So this is 0, 0, 0, 0, 0, 0, 1, 0. Then it is 1, 1, 0. It is 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1 because D7 is 1. So this is how it works. Now what I need to do? I need to look for expressions. What is the expression for y0? If you look at y0, where y0 will be 1? Y0 is 1, 1, then d1 is 1. When y0 is 1, d3 is 1. When this is 1, d5 is 1. When this is 1, d7 is 1. So is it not d1 plus d3 plus d5 plus d7? Okay, from that I will get it. If any one of them is 1, this y0 is 1. So next is y1. If you look at y1 is 1 for what? Exactly d2, then d3, then d6 and d7. So this is exactly known as d2, d3, d2 plus d3 plus d6, d7. Okay. So next what exactly I want? y2. y2 is, what is y2? This is 1 for d4, d5, d4 or d5 or d6 or d7. So this I can implement using OR gate. This I can implement using OR gate, right? So what I can do is I can implement through OR gates. So my circuit will be ready. Now let us look at the circuit, how exactly it look like, right? So in the circuit, if at all you see, you take the inputs. From the inputs, what I try to do is I try to take OR gates, 4 input OR gates, then I will collect them, then my circuit will be ready. So it is something like this. What is that is, I take D0, I take D1, I take D2, I take D3, I take D4, I take D5, I take D6, then I take D7. So these lines are there available. From these lines, what I try to do is I build my output, that is y0. So if you want y0, you take d1, then you take d3, you take d5, you take d7, give it to OR gate. Your y0 is ready. Next you take d2, next you take d3, next you take d6 and d7, you give it to the OR gate, you give it to the OR gate. Then you are going to get your y1. On similar lines, what I can do further is I can extend these lines. Okay. Now what I want to present, what I want to do is I'm further extending them, these lines. I want a D4. So from D4 you take a line, D5, D6 and D7. You give it to the OR gate, then you will get y2. So D0 to D7 are inputs, y0, y1, y2 outputs. This is octal to binary encoder design. So what we started with? We have started with operation. In the operation, what we did is we have analyzed how it works. From that we have seen input output relations. Input output relations. What is input output relations? Which is truth table. From truth table, what we did is we have obtained outputs. So outputs in terms of inputs. From that I got expressions. From expressions, what I did, I have drawn a circuit, which is nothing but the design of octal to binary encoder. Done.